Hello class, welcome to another video for this course. In this video, we're going to start chapter 6 of the textbook, which is all about periodic functions. And in this video, we are going to focus on the first section, section 6.1, sinusoidal graphs. So to introduce this type of function and graphs, let's start by looking at the London Eye Ferris wheel. This Ferris wheel is 135 meters tall in London. You can see the image of this wheel on the right side of this page. And for this one, it takes 30 minutes, half an hour to complete a rotation. Okay, so if we look at the behavior of this Ferris wheel, we see that it takes for it to complete one cycle or one revolution, it takes 30 minutes, and then it repeats this cycle, this revolution over and over and over again. This is an example of periodic function. Why? Because the wheel repeats its revolution or one cycle every 30 minutes. And we say that the period, which means the time that it takes for this wheel to complete one cycle is 30 minutes. So the period of this example is 30 minutes. So in this section, we want to look at functions that have this behavior. It's called periodic function. And then we want to graph them. So formally speaking, a periodic function is a function for which a specific horizontal shift results in the original function. Which means that like you have a behavior, whatever is that behavior, and then after a period of time, or graphically after a horizontal shift, you see again the same sketch, the same graph. And period is the smallest number or the shortest time that you see this repetition. So to start, let's look at these examples, sine and cosine function, because sine and cosine function are periodic function. And the reason is that if you let's look at the table of values. So here we have a table of values for sine and cosine function. The first row shows you the angle, the input value, like 0, pi over 6, pi over 4, and so on. And then the second row shows you the output for cosine function. The last row shows you the output for sine function. And also you can look at those points on the unit circle as well. So here on the circle, we have points corresponding to those angles. Maybe I draw some of them by hand so you can better get a sense of these images. So, I mean, if you want to see all the values here in this table, you have the table of values, and then here you have the corresponding points on the unit circle, and then you have the graph. But I'm going to draw a couple of these points as well. So, so for example, let's look at sine, okay? So for sine, so we are looking at the table of, I'm not gonna do all of the values, just a couple of values to give you a sense. So theta and then sine of theta. So let's say 0. So look at the unit circle. We can do both, by the way. We can do both sine and cosine, like your textbook. And your textbook shows both cosine and sine. Okay, so now let's look at the unit circle. So suppose this is a unit circle. And the angle 0, for angle 0 is right here, right? 0 means no, we don't move from, this is the angle theta equals 0 because it's on the ground. So recall that what is cosine, what is sine. Cosine is the x value So because this theta corresponds to a point, this point has the x value of 1, because this is a unit circle, radius is 1. And so x value is 1, height is 0, right? Cosine is the x value and sine is the y value, the height, okay? So we determined the output value for 0. What else? Pi over 6. Okay, pi over 6. Pi over 6 is here. Pi over 6 is 30 degree. So it's here. Suppose this is 30 degree, or this angle is pi over 6. So it corresponds to some x and y value. We discussed this in previous chapter. For pi over 6, we proved that the x value is the y value is half, the x value is square root of 3 over 2. If you don't remember this, you can go back to the previous chapter and refresh your mind. Cosine is the x value and sine is the y value, the height, right? So that's why here you have a square root of 3 over 2 and then half here. The next one is pi over 4. Pi over 4 is 45 degree. So pi over 4 is right here. Pi over 4. So this is pi over 4, and it corresponds to, do you remember, a square root of 2 over 2 is the x value, a square root of 2 over 2 is the y value. So for angle pi over 4, sine and cosine are square root of 2 over 2 and a square root of 2 over 2, and so on. I'm gonna complete this by 90 degree. So the next one is pi over 3. Pi over 3 or 60 degree, pi over 3 or 60 degrees here, the x value is 1 over 2, half, y value is square root of 3 over 2. So x value, cosine is this, height is this one. And the last angle I'm gonna look at is pi over 2. Pi over 2 is right here. It's right here, 90 degree. You see? Look. This is exactly 90 degree. You see that? This is 90 degree. So what is the x value? 0. What is the y value? 1. So x value 0, y value 1. Okay, so your textbook shows more, goes furthermore. So it shows also 2 pi over 3, 3 pi over 3, 5 pi over 6 pi. I also encourage you to try to look at them and compute them by hand, but I'm gonna stop at pi over 2, and then I'm gonna show you the graph of this sine, for example. Now let's look at the graph of sine. So x-axis, y-axis. I want to draw the graph of sine. So let's plot these points. At 0, look, maybe look it this way. At 0, sine is 0. So that corresponds to the point 0 and 0. At pi over 6, sine is half. So at pi over 6, sine is half. Suppose this is half and this is 1, okay? So at pi over 6, sine function is half. At pi over 4, it's the square root of 2 over 2. At pi over 4, it's a square root of 2 over 2. So it's gonna be here. At pi over 3 is the square root of 3 over 2. Pi over 3 is gonna be here. And then finally, at pi over 2 is 1. So at pi over 2, it reaches 1. Okay, so look, I just plotted how many points? 1, 2, 3, 4, 5. I just plotted 5 points, but of course you can go further, but let's connect them. Okay, so this is so far what we get. So that's the idea, okay? That's the idea, that we just use the table of value and then plot some couple of points to get an idea of how the graph look like. Now look at your textbook. In your textbook, it go further. For example, it look at the output value for 2 pi over 3, 3 pi over 4, pi over 6, and pi, and then it keep plotting those points. And as you can see, it gives us a curve like this. So if you keep working on this, then you will see that the graph goes, so it doesn't pass the height of 1, it goes, it comes back down. And look at here, look at pi. At pi, the output is 0, and that's right, because at pi, so maybe I draw pi as well. Let me explain pi. So you can continue this. At pi, where is pi? Pi is here, 180 degree, right? This theta is pi. What is the x and y value? X is -1, height is 0. So this is -1 and 0, right? So for sine function at pi, it's 0. So at pi, the height is 0. So at pi, the curve reaches back here, right? So, and this is the graph of sine of theta. Okay, and you know that you can give any angle. You can give any angle to this function, and it gives you back the height of the corresponding point. So if you repeat that, so this is the graph of sine just between 0 and pi. But you can keep doing that. You can keep checking more points because the domain is everything, right? So suppose this is x-axis. So if you do that, you will see that the graph behaves like this. So at 2 pi, this is going to be 2 pi. And then it goes like this again. Sorry. And then this again. So this is going to be 3 pi. This is going to be 4 pi, and so on. And also it goes the other way as well. Okay. So the graph of sine is like this, the graph of sine function is like this, and also here also in your textbook also suggests that by plotting more points you can give, we can give a full shape of sine function. This is the graph of sine, and if you repeat the same strategy, just plotting the values for cosine, so now look at the input output value between first and second row, then you can get the graph of cosine, okay? So maybe I'll also draw a ladle for cosine. It would be good if we have side-by-side picture of cosine as well. So for cosine, so in this picture, in this coordinate, I'm gonna draw cosine. Okay, so for cosine, maybe I use green for cosine. Okay, at 0 is 1, right? So at 0 is 1. So that's the point. At pi over 6 is a square root of 3 over 2. So this is pi over 6, pi over 4, pi over 3, pi over 2. Okay. And and this is half. Okay. At pi over 6. Oh, okay, the first one is 6. Is a square root of 3 over 2, which is gonna be somewhere here. So this is gonna be the point. At pi over 4 is a square root of 2 over 2. So it's gonna be somewhere here. At pi over 3 is half. So it's gonna be here. And finally at pi over 2 is 0. So at pi over 2, it reaches 0. So if you connect them, maybe my measurements is not very good because I should get a curve, but something like this. It should go something like that. Okay. And then if you keep doing this, for example, at pi, it reaches -1. So at pi, suppose this is pi. I should have made, okay. at pi is -1. This is -1. So at pi is -1. So your graph is like this. You can plot more points to see why you have to draw it this way. But basically what happens is that if you plot more points, you see that the graph of cosine is like this. So it's like this. It goes this way. And then it goes this way. So at pi, it reaches -1, right? And then here is 2 pi. Oops, sorry. Yeah, this is pi over 2. This is 3 pi over 2. And then like this and this, okay? So as you can see, the graph of sine and cosine are pretty similar, but they are kind of different in terms of, like, for example, if I want to draw, so this is the graph of cosine. But if I want to draw both of them in the same coordinate, maybe that give you a better idea of relationship between sine and cosine. So I'm gonna, so here the red curve is sine. I'm gonna draw cosine in the same coordinate. So cosine is like this. So cosine is go this way. And then this way. And then this way. And then this way. And so on. You see? So this one is cosine of theta. Yeah, I think it would be better if we see the graph of sine and cosine in the same coordinate system. Yeah, now you can see the relationship. Okay, so pay attention that the domain of sine and cosine is all real number. They accept any angle, but the range is between -1 and 1. The height doesn't go beyond 1 and -1. You see the graph is located between 1 and -1. It doesn't pass these two heights. And both of these graphs are called sinusoidal graphs. Why? Because in both of them, the shape of graph begins repeating after 2 pi, right? So look, I'm gonna show you what I mean. For example, for sine, what we have, look at the graph of sine. I'm gonna draw the graph of sine. So what is the graph of sine? It's like this. And this goes forever. It never stops, right? So look, what is the shape? What do you observe here? Look, the shape is that it starts from here, origin, it goes and it goes up to 1, height 1, then it comes back to 0. It goes all the way down to -1, and then it comes back to x-axis again. Okay, right? It comes back to x-axis, right? And here is 2 pi, right? So it starts from 0. Look, I mean, it doesn't start from 0. My drawing starts from 0, right? And then we have this graph. But look, at 2 pi, we just have the same, it's like we repeat it. We have the same copy of the same thing. Look, it goes up from 0 to 1, it comes back to 0, go all the way down to -1, and again reaches to 0. So this green one, this green drawing is like a copy of the red one, right? And again, we have a repetition of the same thing. It starts from ground, goes up all the way up to 1, comes back to 0, goes down up to -1, comes back to 0. You see that? So it's like the shape is the same thing. It's just get repeated. And what is the repetition? The repetition happens over 2 pi. Look, so it's like from 0 up to 2 pi. You see that? If so, between 0 to 2 pi, we draw the graph, but after that we have a repetition over each 2 pi, because this is also 4 pi, this is 6 pi, and so on. So the repetition, the period that it completes this rotation is like 2 pi. This is the graph of sine function. So for sine function, as you can see, okay, the graph has a shape. It has one rotation, one full rotation over 2 pi. And then after that, it repeats the same rotation. It gives us the same shape over each 2 pi. So that's why we say that this is a periodic function. So sine is a periodic function. What is the period? The period is 2 pi, because it gets repeated, the graph gets repeated over each 2 pi, after each 2 pi, okay? So, and the same thing happens for cosine. So in both of them, the shape of the graph begins repeating after 2 pi. And so you get the same output value for the angles after 2 pi. That's why, so for example, look, whatever is the angle, right? So suppose this is your angle, you get the same output after 2 pi. So that's why, maybe I show it to you here. Look, suppose you have an angle, right? For example, theta is an angle here, right? After 2 pi, this is after 2 pi. So this is theta plus 2 pi. You are still at the same height. You see that? What is this? This is sine of theta. So this is sine output, sine of theta. You see, at this theta, you have sine of theta, which is the height of this graph. And you see, theta plus 2 pi, after 2 pi, you still have the same height. So the output for this is still the same, you see? And that's the property or characteristic of periodic function, that, or in other words, after 2 pi, wherever you are at theta, wherever you are, after 2 pi, which means that adding 2 pi to it, you still get the same height, the same sine, the same height, the same output, and same thing happens for cosine. So in other words, if you were to shift either graph horizontally by 2 pi, the resulting shape would be identical to the original function, exactly like what I draw here. I started by the red one, and then it's like having a horizontal shift and just keep repeating the same graph. So the periods of sine and cosine, both of them are 2 pi. And here you have the graph of sine and cosine side by side. Okay. And another characteristic of sine and cosine is that the sine is an odd function because it's symmetric toward origin, right? So sine of negative theta is negative sine of theta. Any odd function has this characteristic. How do you know it is an odd function? Because the graph is symmetric toward origin. But cosine is even because it's symmetric about y-axis. You see that? Y-axis is for cosine, y-axis is like a mirror for the graph. So the symmetric axis is y-axis. That gives us an even function. What was the property of even function? Cosine of negative input is the same as cosine of the positive input. So cosine of negative theta is cosine of theta. And there are many properties, but I think last chapter we looked at the relationship, look at this identity, the relationship between sine and cosine. This is co-function identity. Co-function identity, sine of theta is the same as cosine of pi over 2 minus theta. This is one of the identity we introduced last chapter, and here it's just showing using this in order to show another way to discuss this. But usually we look, these properties have many applications, but one of the application is just simplifying. Like here in this example, you are given a trig expression, and the question is simplify it if you can. So I'm going to show you example 1. So simplify sine of negative theta over tangent of theta, right? Sine of, okay, so we just saw that sine of, so we want to simplify sine of negative theta over tangent of theta, but we just saw that sine is an odd function, right? So that means sine of negative theta is the same as negative sine of theta, right? So here I use the fact that sine is an odd function. Therefore, sine of negative theta can be replaced by negative sine of theta. What else can we do here to simplify? Tangent, now we can simplify tangent. Tangent is what? Tangent can be written as sine over cosine, right? Because we know that tangent of theta is the division of sine and cosine. So I'm going to replace tangent by sine and cosine. Now we are ready to simplify, because here you can cross this by this, and then if you simplify, you get negative cosine of theta. That's it. So we simplified this trig expression into negative cosine of theta. Example 2, a point rotate around the circle of radius 3. Sketch a graph of the y-coordinate of the point. So y-coordinates of the points would be sine. Okay, so in this example, the question says, the point is rotating around a circle of radius 3, right? So you have point P, which has some x and y value, right? And it gets rotated around the circle of radius 3. So just recall that the x value, right? This x value is cosine of, because it creates theta, right? It's cosine of theta, and the y value gives us the sine of theta. So y value is the sine of theta, x value is cosine of theta. And the question says, sketch a graph of y-coordinate. Y-coordinate is sine. So that means I need to sketch the graph of sine. X-axis, y-axis. Okay, so here is the thing, because I mean, you can try a table of value if you want. Theta and y equal sine of theta. For example, if you try 0, so at 0, the height is 0. If you try, I don't know, pi over 2, at pi over 2, this is gonna be, we know that sine of pi over 2 is 1, but because the radius is 3, this is gonna be multiplied by 3, recall? This is gonna be multiplied by radius, so it's gonna be 3. And so on, right? So, or you can try more values. For example, at 3 pi over 2, okay, we know that sine is -1, but because radius is 3, we multiply by 3, so it's going to be -3. So basically, what happens is that the graph is going to be the graph of sine, but it's going to be between +3 and -3. So I'm going to draw the graph of sine, but I know that instead of, because it's not unit circle, because the circle has radius 3, so this sine is going to be like this. The graph is going to be like this, okay? So it's the graph of sine, but something like this, right? This is pi over 2. This is 3 pi over 2. Okay, and so okay. So the only trick is that because y is r sine of theta, now we multiply sine by the radius 3. So it's like, this is like a stretch. It's like you have lyrical transformation. It's like you have the graph of sine multiplied by 3. So you're stretching the graph. So since the outputs of this graph will now oscillate between -3 and 3, we say that the amplitude of the sine wave is 3. So originally sine oscillates between -1 and 1. So amplitude is 1. But in this case, because it's between -3 and 3, we say that amplitude of this function is 3. Okay, makes sense? Another definition is midline, the center value of a sinusoidal function. The value that the function oscillates above and below is called the midline of the function. And for a function like if f is cosine plus k, then it has the midline at k. So I'm gonna just put it in a graph to give you an idea of what's the difference between amplitude and, so just look at the sine, for example, or the cosine, it doesn't matter. Cosine. So this is the graph of cosine. By the way, it goes forever, it never stops, because the domain is everything, right? Okay, so this is the graph of cosine. So what is the amplitude? Amplitude is, because, okay, maybe I write this down. This is the graph of cosine of theta. Amplitude is 1, because this is 1 and -1, right? 1 and -1. So what is the amplitude? Is 1. Okay. So for this graph, the amplitude of this cosine wave is 1, which means that the graph wave between 1 and -1. What is the midline? Midline is this x-axis. In this case is x-axis. Why? This is the midline. It's kind of like your wave, your graph oscillates above and below of this line, or it's just in the middle of the graph. So this is called midline, midline. Okay, so midline. So the center value, this is the definition, the center value of sinusoidal function, the value that the function oscillates between, oscillates above and below is called the midline of this function. So in this case, the midline is x-axis. Okay. Okay, so so we saw that the midline is the is the line that the function oscillates above and between. And for sine and cosine, you can see that the midline is x-axis. Let's look at example 4. It says a point completes one revolution every 2 minutes around a circle of radius 5. So the fact that let's understand this one by one. The fact that says the completion, one completion rotation is every 2 minutes, that tells us that the period is 2 minutes. Okay, so I'm gonna summarize this question over here. Example 4. Example 4. So the period is 2 minutes. One complete rotation takes 2 minutes. And the radius of the circle is 5. So R is 5. Radius is 5. What else? Find the x coordinate of the point as a function of time if it starts at 5 and 0. Okay, so look, I mean, if you can look at the circle, so this is the circle, x-axis, y-axis, radius is 5, right? And it says if it starts at the point, if it starts at 0.5 and 0, so that means right here, 5 and 0. This is the 0.5 and 0. It starts from here to start the rotation. Then it says express the x coordinate as a function of time. Okay, so x coordinate is what? Is the cosine of time, right? So x gives us the cosine, right? So this is a cosine function. That's what I'm trying to say. The x coordinate of a point on a circle is the r cosine of theta. Yes, because this is not unit circle, it's r times cosine of theta. So it's going to be r times cosine of theta. Right, and here is r is 5, so it's 5 cosine of theta. So x is 5 cosine of theta, right? And then because the period is what? The period is every 2 minutes. Okay, so the rotation is every 2 minutes, right? And that means 2 pi. We know that for cosine the period is 2 pi, right? And here, how should I explain this? So the rotation is, the one complete rotation is 2 minutes. And we want to find a formula of angle, we want to find a formula that expresses angle as a function of time, okay? So the point begins at 0, angle 0, that's right. And then the points rotates one rotation for 2 pi. In terms of angle, the one rotation is 2 pi. Every 2 minutes. So it rotates pi every minute. That's right. That's right. Because if it takes, look, one complete rotation, which is 2 pi, takes 2 minutes. So halfway through, which is pi, takes 1 minute, right? So after 10 minutes, it will have a rotation of, so how can I say it? Look, if after 1 minute, right? The rotation is pi. So after, in general, t minute, any minute, the amount of rotation is a multiplier of pi. So t pi or pi t. Okay, that's pi t. It doesn't matter. Yeah. Okay, so that's it. So in terms of time, it's cosine of pi t. So the function in terms of, because this is in terms of angle, right? But the question says that expresses in terms of time. So in terms of time, it's pi t. This is time. Okay. And here we can discuss about, the period, because look what happened. And this is the graph. This is the graph. As you can see, the graph has the shape. This is a cosine graph. This is a transformation of cosine graph. First of all, there is a stretch for 5, because the graph is a stretch for 5. It's multiplied by 5. Amplitude is 5. Midline is still x-axis, but period is different. Now there is a new period here. For t, because t is time, we draw the graph not based on angle, based on time. The period is 2 minutes. So if you want, I can also draw it here. Look. So this is the graph. X-axis, y-axis. So it's between 5, and the rotation is between 5 and -5, right? Between 5 and -5. The graph is a cosine graph. So it's going to be like this. So the graph is a cosine graph. By the way, this is t, time. And one complete rotation. So let's say we start from here, right? 0. And then one complete rotation is going to be here. This is 2 minutes. So halfway through is 1 minute, which is exactly pi. So I mean, in terms of angle, this is a complete rotation is 2 pi. We know that. In terms of angle, a complete rotation is 2 pi. But in terms of time, so if you're looking at this as an angle, a period is pi. But if you're looking this as time, period is 2 minutes. Okay. So as you can see, so we want to see how period relates to stretch and compression effect, coefficient in the multiplier of whatever is the input. There is the input multiplier, right? What is the effect on period? So it says if a point takes p minutes to complete one rotation, then 2 pi, because one complete rotation is 2 pi, divided by whatever is the time that it completes to take that. So one complete rotation is 2 pi. P is the time that it takes to complete this rotation, right? So in this way, this multiplier is the multiplier for time. And in this way, we can express our function in terms of time rather than in terms of angle. And from here, we can also find period, because we can determine the relationship between coefficient and the period. Whatever is the coefficient, for example, you have sine of b theta, right? What is the coefficient? It's b. We saw that b is 2 pi over p, right? So from here, we can solve it for p, right? We can say that period is 2 pi over b. So it's like going reverse. So suppose you are given a function. Let's put this together. Suppose you have a function. This is a sine function. there are multiplier. Sine is multiplied by A. Okay, that's gonna give us the stretch. The input is multiplied by B. Okay, that's gonna give us a new period. And there is the output is added to K. Okay, that's gonna vertically shift the midline. And same thing goes for cosine. So what is A? A is the vertical stretch and is the amplitude of the function. What is B? B is the horizontal stretch and is related to the period. We can determine period by 2 pi divided by B. And what is K? K is the vertical shift that determines the midline. You can see that in this graph as well. For example, what is the period of this function? This is example 5. Example 5. What's the function? F of t is sine of pi over 6 times t. And the question is, what's the period of this function? So as you can see, this is a sine function that is multiplied. This is your b, that is multiplied by a value. The input is multiplied by a value. So recall that b is what is the full rotation for sine? It's 2 pi. And divided by period, right? Whatever is the period. So that's the way, that's the relationship between b multiplier b and period. P stands for period. Okay, so let's solve it. B is pi over 6, 2 pi. Then we can, from here, we can solve for P. So from here, P is gonna be 12. That's it. Period is 12. Okay. Or for example, here a graph is given, determine the midline, amplitude, and period of these functions. 3 sine of 2t plus 1. Okay, this is next example. The function is 3 sine of 2t plus 1. Example 7, f of t. Okay, okay. So 3 is there. Look, the function is multiplied by, this is your a. The function is multiplied, the input is multiplied by a value, and this is your k, right? And okay, so what is the stretch? The stretch is 3. So amplitude is gonna be 3. What is the midline? It's gonna be 1. It's gonna be 1. What is the period? What is the period? Okay, so B is 2 pi divided by period. B in this case is 2. So P is gonna be pi. So P is pi. And if you want to draw it, the graph is gonna be like this. So it's between 3 and -3. So the graph oscillates between 3 and -3. And oh, the midline is 1. Let me draw the midline because there is a vertical shift. So this is the midline. This is the midline. So the graph is gonna be like this. And this is a cosine function. So it's gonna be like, cosine is like this, 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 and this. And period is pi. So that means this is pi. This is pi, this is 0. It takes pi to complete one full rotation. Okay. So amplitude is 3, period is pi, midline is y equal 1. And yeah, for example, find a formula for sine for this graph. So the graph is like a sine function. I can see that this is a sine function, but it's a transformation of sine function. So first of all, the height goes up to 3. So amplitude is 3. Sorry. The graph oscillates from -1 to 3, right? The graph oscillates from -1 to 3. And the midline is just in the halfway through. So it's at 1. The midline is at 1. Okay, so the amplitude is 2 because between -1 and 3, the middle is 1. How many units up and down it goes? 2 units. So amplitude is 2. The distance between highest value to midline is 2. Okay. And the period is 8. I would like to show this on the picture. Let me see if I can take it. I would like to explain this on the graph. Okay, look. So here the graph oscillates between, between -3, right? And -1. The midline is right here in the middle, right? This is the midline. And so the amplitude is 2 because you see it's 2 units above, 2 units down. So amplitude is 2. So if you want to write f of t, whatever, it's 3 times sine of something plus amplitude is 1. So plus 1. Okay, what do we need to find? We need to find what is the multiplier of t. We need to find a multiplier of t. That depends on period. So now let's discuss period. So for period, I'm gonna erase this part because I'm gonna explain the period. For period, look, for example, a full rotation. A full rotation, let's say we want to find a complete rotation. For example, you may look at here. For example, it goes up, down, here. This is a complete rotation, right? The rest is just, this is a full rotation, for example. And okay, 4 units here, 4 units here. So it's gonna look 4 units here, 4 units here. So it's gonna be 8. So period is 8. You could also see that in this way. You could also see the period. Again, one more time. This is the midline. This is the midline. And you could also look at the period in this way. This is a cosine function. So it starts from here. It starts at the height of 1. Then it goes all the way down. It comes back to height of 1. So that's actually the way we look at cosine. Because when it starts at the height of 1, it completes 1 full rotation when it goes back to 1. And then you can look at the distance. What is the distance? 2 units to the left and 6 units here, so it's 8 units, right? So period is 8. So now we can solve it for B. B is 2 pi divided by P. So it's 2 pi divided by 8. So it's going to be pi over 4. So that's going to be pi over 4. Okay, so 3 sine of pi over 4t. So that's the function. Oh, why did I say 3? I'm sorry. The amplitude is 2. The amplitude is 2. And I think I explained that, but I wrote 2. The amplitude is 2 because look, how many units? 1, 2 units above the x-axis. So this is 2 units. And then 1, 2 units. So the graph oscillates between 2 units above and below the x-axis. So amplitude is 2. The stretch is 2. So 2 sine of pi over 4t plus 1. That's it. The graph is, oh, I forgot about the negative. Yes. Because sine is, I'm going to explain why this is negative. Because the graph of sine, so I'm going to draw a graph of sine. So this is the graph of sine. Sorry, my bad. Right? This is the graph of sine. If it was positive, we should have this one. But do you see there is a reflection? There is a reflection. That's because the graph was multiplied by a negative. So for example, look at here. If it was positive sine, we should have this part above x-axis, but now we have it under the midline. So why? Because it is multiplied by a negative sign. There is a reflection. This graph is a reflection of sine toward x-axis, horizontal axis. That's why the graph is negative 2 sine of pi over 4 t plus 1. Okay, I think that's all. There is also something about phase shift. But I think that's enough for now. Yeah, I think as long as you understand the periodic function, you understand and be able to draw a graph of sine and cosine function from unit circle, understand the dominant range, sinusoidal graph in general, and the identities, negative angle on the identities, and also transformation. You should know what is the amplitude, what is the midline, what is the period, and know about horizontal shift. So I think now you should be able to do the exercises of this section. Thank you for watching this video. I'll see you in the next one.